So what we're going to talk about in this section has to do with the measures of central tendency and dispersion that we've already discussed, and we're going to look at that from the perspective of group data. So essentially, instead of knowing each and every individual data point, we're instead just going to have information about a range of numbers within which the data will fall. And so maybe we won't have like 81, 86, 87, 88, but we'll just say that there are three values between 80 and 89, something along those lines. That is grouped data. And so what you can do is find a weighted mean, or sometimes this is what's called a weighted average. A common application of this is actually how GPAs are calculated. And so depending on the hours, the credit hours of a course, it carries more weight in terms of the impact on a student's GPA than a course with fewer credit hours would. So here we've got this student here. They've got a chemistry class. It's 4 credits with a C. Statistics is 3 credits with a B. Communication. So you got all these. They tell us that an A is worth 4, a B is worth 3, a C is worth 2, a D is worth 1, and an F is worth 0. So what we're going to do here, we've got the credits. And then we're going to have the grade, and we're going to change that into a number. And so what we're going to do is find the grade points, which is just going to come from multiplying the credits by the grade. So credits times grade equals grade points. For the credits, we have 4, 3, 3, 3, 3, 2. So this one is chemistry. This one is stats. This one is communication. You've got econ. English, and then seminar. So the grades for all these, chemistry is a C, that's going to be equivalent to 2 grade points. Stat is a B, that's going to be 3. Communications is an A, which is 4. Econ is a B, that's 3. English is a D, which is 1. And then seminar is an A, which is 4. So we're going to multiply all these numbers going across here. So this is going to give us 8 grade points. 3 times 3 is 9. 3 times 4 is 12. 3 times 3 is 9 again. 3 times 1 is 3. 2 times 4 is 8. If you add up all the credit hours, you've got 3, 6, 9, 12, and another 6. So this student took 18 hours. That's what we're going to divide by. Over here, we're going to add up the grade points. So let's see what we have. 8, 9, and 12. Okay, so we have 8 plus 9 plus 12, and then we're adding to that 9, 3, and 8. You add that all up, you end up with 49 grade points. So then to find the GPA, you're going to take the grade points and divide it by the credits. You're going to do 49 divided by 18. And let's find out what that is. That is 2.72 for the GPA. And so because a B is worth 3, that would probably be sort of roughly in the ballpark of like a C plus ish GPA. So if you have data where you don't have access to the original numbers, but you have group data, as I mentioned before, you can make what's called a frequency distribution. And even if we don't have access to the raw scores, we can make a rough approximation of the summary statistics that we've discussed earlier based on the frequency distribution. So we're going to talk about how you would do that. So essentially, you're going to have the population mean. It's going to be the sum of all the frequencies times the midpoints of the class intervals. And so if you do all of the frequencies divided by, if you do the frequencies times the midpoints, add those all up, and then divide it by the sum of all the frequencies just by themselves, that is going to give you the sample mean or the population mean, depending on what you're referring to. And then there's a process by which you can find the standard deviation. If we're going to do this in the calculator, what we'll want to do, we're going to put the class midpoints in list number 1. We're going to put the frequencies or relative frequencies in list number 2. Tells us to go to stat, over to calc. We're still going to do 1-bar stats. And then this time, on an 83, you're going to do L1, comma L2, or on the 84, it will have an option for you to choose a frequency distribution option. So let's kind of get to this and see how this works. So if we're going to do the class intervals, essentially what you have to do is find the average of the endpoints of each class. So the first class is 91 and 100. You're going to find 91 plus 100. And then divide that by 2, which is going to give you 95.5. So you add up the numbers and divide by 2. You do likewise with 81 plus 90. Those are the endpoints of the next class interval. If you work that out, you will get that should be 0.5, sorry. This will give you 85.5. And it turns out that the averages are always going to be the 5.5 of that range. So basically this one is 95.5. This one will be 85.5. This is 75.5, 65.5, 55.5, 45.5, and 35.5. So it's just the 5.5 value of each of these intervals. And the way you find that is you simply do the low end of the interval plus the high end of the interval, add them up, and then divide by 2. So I'm going to pause things real quick. I'm going to enter all of these values into list 1. These class intervals are going to go in list number 1. And then the frequencies are going to go in list 2. And I'm going to pause for a moment while I do that. All right, so in list number 1, as promised, we have put the midpoints of each of the frequency ranges. In list number 2, we are putting the frequency distribution. So that basically means there are 4 scores between 91 and 100. You can have 92, 95, 97, 98, or something like that. We don't know what those 4 scores are, but on average, they're going to be roughly this value because it's the middle value. And for what we're trying to do, it'll be a close enough approximation with what we have to work with. So after you get all the values typed in, you're going to go to Stat, go over to Calc, and again, pick one var stats. For the list, that's in list 1. Here, since we're doing a frequency list, we're going to do list 2, L2, and then go down to where it says calculate, press enter. As before, this is going to give us the mean, the standard deviation of each of these. And so let's see what we have here. Use this to approximate the mean and standard deviation of this exam. And note that they say do population data. So remember that the Greek letters, in this case sigma, that is going to be the standard deviation to use for a population. So in this case, the mean, which for a sample is called X bar, but here it's going to be mu, 71.68 if you round that off. And then we want sigma of X because we are told this is to be treated as a population. So sigma of X is 16.09. And so we now have a mean and standard deviation approximately based on the frequency distribution. Again, we don't know the specific scores in each of the grade ranges, but we can still find summary statistics based on aggregated or grouped data. So that is the end of section 3.